A function f(x) has the first derivative f prime equals 2x squared minus 7 minus 4 over x squared. Part A, given that f of 1 is negative 1 over 3, find f(x). To find f(x), we find the integral of f prime x. So we integrate 2x squared minus 7 minus 4 over x squared. This 4 over x squared can be written as 4x to the negative 2. It would be easier to integrate if we write it this way. And then the integral is 2 over 3x cubed minus 7x minus 4. Negative 2 plus 1 is negative 1. So minus 4 over negative 1x to the negative 1 plus c. And this is 2/3 x cubed minus 7x plus 4 over x plus c. We are given that f of 1 is negative 1 over 3. So we replace x with 1 and f(x) is negative 1 over 3 to find the value of c. So 2 over 3, 1 to the 3 minus 7 times 1 plus 4 over 1 plus c. This is negative 1 over 3. And then we have 2 over 3 minus 7 plus 4 plus c equals negative 1 over 3. Isolating c, that is negative 1 over 3 minus 2 over 3 plus 7 minus 4. And this will give a value c, which is 2. Then f(x) here is given by 2 over 3x cubed minus 7x plus 4 over x plus 2. Part B, find the coordinates of the stationary points on the curve. Stationary points occurs when f prime x is 0. So we set f prime x to 0. 2x squared minus 7 minus 4 over x squared equals 0. And we need to solve for x. In order to do that, multiply throughout by x squared, so that we have 2x squared, 2x to the 4 minus 7x squared minus 4 equals 0. This is actually a quadratic in terms of x squared, and we can factor this to be 2x squared, x squared here, and that is a 4 and 1. So 2x squared plus 1 and x squared minus 4 equals 0. To solve for x, we set 2x squared plus 1 equals 0, and x squared minus 4 equals 0. From this part here, we have x squared equals negative 1 over 2. This is impossible. The square of a number cannot be negative. X squared minus 4 equals 0. X squared equals 4. Then x is plus minus 2. There are two stationary points. One is when x is negative 2, and the other one is when x is 2. To find the coordinates of the stationary points, we need to find the y coordinates as well. When x is negative 2, then the y coordinates is f of negative 2. We substitute into this part here, fx. So we have 2 over 3, negative 2 to the 3 minus 7, negative 2 plus 4 over negative 2 plus 2. And this is 26 over 3. So one of the stationary points has coordinates minus 2 and 26 over 3. The second stationary point occurs when x is positive 2. When x is 2, f of 2 here is 2 over 3. 2 to the 3 minus 7 times 2 plus 4 over 2 plus 2. And this is negative 14 over 3. Then the second stationary point has coordinates 2 and negative 14 over 3. We have these 2 points here, 26 over 3 and also 2, negative 14 over 3. Part C. Find the second order derivative of f. So we need to differentiate fx. So to differentiate fx, we have to differentiate 2x squared minus 7 minus 4x to the negative 2, and that is 4x plus 8, 4 times 2, that would be 8 over x. So we have 4x to the 3 here minus 1. So plus 8 over x cubed. That would give us the second order derivative. And D. Hence or otherwise determine the nature of each of the stationary points. We need to determine whether the stationary points is a local max or a local mean. Let's look at the first stationary point. The second order derivative at negative 2. So you have 4 times negative 2 plus 8 over negative 2 to the 3. So that is negative 8 minus 1. So this is negative 9, which is less than 0. If you have the value of the second order derivative to be negative, then that would give you a local maximum. The stationary points with coordinates negative 2 and 26 over 3, this is a local max. Now we evaluate the second order derivative at x equals 2. So we have 4 times 2 plus 8 over 2 to the 3. That is 8 over 2 to the 3. So 8 plus 1, that is 9, which is positive. Then we say that the points with coordinates 2 and negative 14 over 3, this is a local minimum.